These are the notes for 2-5 on compound inequalities. So a compound inequality is when two inequalities are joined by the words and or. Okay, these create the two different types of compound inequalities we could have. We'll have and inequalities, where the solutions to the compound inequality have to meet both parts of the inequality. And we'll have or compound inequalities, where the solutions could be true for one or the other. So first, let's start by graphing. So number 1 and number 2, those are considered and inequalities. For and inequalities, we won't typically have the word and, but we'll start by writing the word and just so we get used to them. But eventually I'd like to see us write our compound inequalities when they're an and, like number 1 and 2. So what number 1 is saying is we want to read this inequality inside out. So start with the left side. This is saying x is less than or equal to 2, and x is greater than or equal to -1. So we want to plot. Our number line needs to have the values from at least -1 to 2. So I'm going to start at -2. I'm going to sketch the shading first, and then I'll finalize it in just a minute. So first, let's graph x is less than or equal to 2. Filled in, shaded to the left. X also needs to be greater than or equal to 1. Filled in, shaded to the right. So the solution is where the two shadings overlap. So where they overlap is the values between. So we don't need these lines here, but they just help us kind of get started and help us see that the two shadings overlap between those two endpoints. Let's try another and inequality. So again, read it from inside out. X needs to be less than 5, and greater than or equal to 2. So we'll graph, and then the shading that represents the solutions will be wherever the shadings overlap. So x needs to be less than 5, so open at 5, shaded to the left. Greater than or equal to 2, so shaded to the right. And again, where they overlap is the shading in between. So and inequalities will always be shaded in between those two endpoints. For or inequalities, we graph these separately on the number line. So if we first start with x needs to be less than -3, or x can be greater than or equal to -1. So and inequalities are shaded in between those two endpoints. And then OR inequalities are shaded in the tails of the number lines. So that's how we graph compound inequalities. Now let's look at a graph and write the inequality. So number 4, we know it's an and, right? Because it's shaded, we have that overlapping region and it's shaded in between. So let's start with the left side. For this to be the overlap, it would have to be x is greater than or equal to 6. And for this to be the overlap, we would have had to shade to the left for 10, so less than or equal to 10. So when we go to write the compact compound inequality, start with your two endpoints, put x in the middle, and then fill in the right side first because the variable will be on the left. So fill in less than or equal to, and then follow that same direction for the left side. For and inequalities, the inequality symbols will always be facing in the same direction. We'll always have one less than and one greater than. This one here is less than or equal to, and this one is greater than or equal to. It's just weird because the variable is on the right. Number 5 is an OR, and we can tell because the shading is then on the two tails of the number line. So we have x is less than 7, or x is greater than 9. And that's it. 6 is also an OR compound inequality. We have x is less than or equal to -2, or x is greater than or equal to +2. And 7 is an AND inequality. Start with the left. For this to be the overlap, we would have had to shade to the right. So x needs to be greater than -3. And for this to be the overlap for +1, we would have had to shade to the left. So x also needs to be less than or equal to 1. So now let's write this as a compact compound inequality. Start with your two endpoints. Put the variable in the middle. Fill in the right side first, less than or equal to. That one's always easiest to start because the variable is on the left. And then we have x is greater than -3, so we fill it in there. And again, the inequality symbols are both facing the same direction. So that's graphing compound inequalities, writing compound inequalities. Now let's get to solving compound inequalities. So for and inequalities, our goal is to isolate x in the middle. So whatever you do to the middle in order to get x by itself, we have to do to the middle, obviously, but also to the right and to the left. So those two inequality symbols kind of create three parts to this inequality. So we're multiplying x by 2 in the middle. So to isolate, we'll divide all three parts by 2, and then just simplify. So graph the two endpoints, open at 2, closed at 4. It's an and, so it's shaded in between. X is less than or equal to 4 and greater than 2. And those values here are all the values that are both less than or equal to 4 and greater than 2. For 9, in order to isolate x, we first want to add 1 to all 3 parts. I think these lines kind of help you remember, and it helps you kind of stay organized as well. So -4 plus 1 is -3. We've got 3x in the middle, +6 on the right. We're multiplying x by 3, so we want to divide all 3 parts by 3, and then simplify and write your compound inequality. Now, the same rules apply to solving compound inequalities as they do to solving simple inequalities or one-sided inequalities. And that's if you multiply or divide both sides by a negative number, you've got to flip that inequality symbol. With and inequalities, if the middle value is negative, you're going to have to flip both inequalities because you're dividing all 3 parts. But for or inequalities, you would just do whatever inequality you divided a negative number by. So time to graph. Endpoints are at 2 and -1. It's an and, so we shade in between. Okay, so that's solving an and compound inequality. Isolate x in the middle. Whatever you do to the middle to isolate x, you have to do to the right and to the left as well. Don't know where to put myself. For or inequalities, we're going to solve them separately. So it's really just 2 inequalities in one problem because we're also going to graph them separately. So for 10, let's start with the left inequality first. I'm subtracting 2, so I want to add 2. Four times x, so I want to divide both sides by 4. So one part of the inequality is x can be less than 1. Moving to the other inequality, we're subtracting 3, so we first want to add 3. Multiplying x by 2, so we want to divide both sides by 2. Include the word or in your solution. So we get x is less than 1 or x is greater than 5. So x is less than 1 or x is greater than 5. Shaded in the tails. Okay, for 11, same thing. Solve the 2 parts of the inequality separately. So first we'll solve the left one. Two times x, so divide by 2. We get x is less than -5. For the right inequality, we first want to deal with that +5, so we're going to subtract it first. -3 times x, so we want to divide both sides by -3. So it's what I was talking about before. It's that step there that we have to flip the inequality symbol. And we're just going to flip the inequality symbol of the inequality that we divided a negative number for. So the solution is x is less than -5, or x is greater than or equal to +3. I'm going to start at -7 and increase by 2. I have these consecutive odd numbers so I can fit everything. Now, if you know it's an OR inequality, but it doesn't graph like an OR inequality, that means something went wrong with when you were solving. So you'd want to check, did you divide by a negative? Did you just add incorrectly or divide incorrectly? Because your OR inequality should always be graphed in the tail ends of the number line. This or that. Less than 1 or greater than 5. Less than -5 or greater than or equal to +3. Okay, so that's it for solving compound inequalities. Last up, we want to represent the situation as a compound inequality and then do an error analysis problem. So you are a New Hampshire state trooper who is assigned to work traffic enforcement on Route 101. The minimum speed is 45 miles an hour, and the maximum speed is 65 miles an hour. You need to detect vehicles that are traveling outside the posted speed limits and write these conditions as a compound inequality. So when I first read this problem, I wasn't sure if I should write a compound inequality for those following the speed limit or for those that weren't following the speed limit. So I opted to show you both, and that way you'll have one example of an AND inequality and one example of an OR inequality. So first, if the minimum speed is 45 miles an hour, we could translate that to be the speed needs to be greater than or equal to 45. The maximum speed is 65. We can translate that so that x needs to be less than or equal to 65. For those following the speed limit, you have to travel between 45 miles an hour and 65 miles an hour. So you have to be going greater than or equal to 45, but you also have to be traveling less than or equal to 65. So for an AND inequality, if you can squeeze the word between in, then that means that it's an AND inequality. If you're following the speed limit, you're going between 45 miles an hour and 65 miles an hour. So if we want to write this as a compact compound inequality, start with the two endpoints, put the variable in the middle, fill in the right side first, and the left side next. So x needs to be less than or equal to 65 and greater than or equal to 45. So for those not following the speed limit, if the minimum speed is 45, you're not following the speed limit if you're going slower than 45 miles an hour, or if you're going faster than 65 miles an hour. So those are two ways that we can represent this situation as a compound inequality. If you're traveling between those speeds, it's an AND inequality, and you're following the speed limit. If you're traveling outside that range, you are not following the speed limit, and we can express the inequality with an OR compound inequality. And then we have an error analysis problem. So Susie Q solved the following compound inequality, and we want to find, describe, and correct. So I always start fresh, see if I can find it when I solve, check each step against mine, and see if we can find out what went wrong. So we started here. Her next step matches mine. However, when we would go to graph, x is greater than 5 would be shaded to the right, or x is less than -10 would be shaded to the left. So it looks like Susie Q solved this inequality correctly, but graphed the inequality as an and compound inequality when it should be an or compound inequality. That's it for the notes for 2-5 on compound inequalities. We covered how to graph a compound inequality, how to write a compound inequality from a graph, whether it's an and or an or. And inequalities are shaded in between, or inequalities are shaded in the tails. Solving and inequalities, isolate x in the middle. Whatever you do to the middle to isolate x, you also have to do to the right side and the left side. And solving or inequalities, you solve them separately, and then you also graph them separately. It's either this or that. We can represent situations as compound inequalities, whether they're an and between two numbers, or whether it's this or that. If you have any questions, please don't hesitate to reach out.